Good afternoon. My name is Dwayne Brandt, Portland Fire and Rescue's Safety Officer. And my guest today is Dan Rossos, former lieutenant, retired lieutenant. Portland Fire and Rescue was with us for 28 years, 29 years?
27 years.
27 years. Dan is with us today. We're going to be talking about thermal lens, SCBA lens, and thermal degradation with it. And how this all started was back when I became the safety chief. Dan and I met just to discuss some trends that were going on in the nation, and I asked Dan, what we could do from my position. And Dan went into some stories that talked about things that were trending on the national level, alarming stuff that was with our PPE. And Dan, maybe you could talk a little bit about our discussion there on that day, and about maybe talk to him about how you first got introduced to what was going on, and then how you got involved with about the lenses.
All right, I'd be more than happy to, Chief. Thank you. As the Chief indicated, I work now. I worked prior to my retirement, but I still work with the NFPA on some of their committees, and specifically the Respiratory Protection Committee, which designs breathing apparatus. And one of the members of our committee, we're fortunate to have, works with NIOSH as a firefighter fatality investigator. And about 3 years ago, I was contacted by that investigator, and he indicated to me that he was on scene of an unfortunate incident where a firefighter had perished, and that there was some unusual characteristics that he was saying regarding the thermal impact to the lens. He at that time thought that perhaps the firefighter was still breathing when this lens went away or melted away, just because of some of the physical evidence, and later autopsy results indicated that he was correct, and that this firefighter, as far as we can tell, was still breathing when his lens melted. At the time, obviously, as alarming as that was, it was the first time that we'd heard about an incident like that occurring. Within a relatively short period of time, I was contacted again with looked to be another fire fatality that looked like it had the same evidence. And shortly after that, 2 more. At that point in time, I initiated a task group with the NFPA under NFPA 1981, the Respiratory Protection Committee, and we were able to attach to that committee members from that committee itself, as well as from NIOSH's Fire Fatality Investigative Division, from the National Institute of Standards and Technology, and from the NFPA Research Foundation, as well as every manufacturer of SCBAs and a number of the turnout manufacturers. And then over the course of, I guess it's been about 3 years now, we've just continued our investigation to try to figure out exactly what caused this, and if there was something perhaps we could do in NFPA 1981. And that's where we're at right now. I think we have some evidence that's quite compelling, that is a little confusing, but yet I feel privileged that NIST and NIOSH have given Portland the opportunity to be able to view some of these photographs and be able to discuss some of these issues, even though they're at this time still ongoing investigations.
One thing that I think we want to, real quick, before we start getting into the PowerPoint, is the fact that NIOSH and NIST has allowed Dan to bring this forward, show us this. We need to respect the fact that some of the stuff we're going to see isn't out across the nation. There are firefighters that have passed away. Their families haven't seen any of this, so there's no copywriting. We can't copyright this and then pass it on. The copywriting, there is copywriting, is what I'm saying, and we can't pass it on to anywhere else. And it's very sensitive. And if that were to get into someone's loved ones, it would be terrible. So,
and as the chief just indicated, I feel very grateful to the individuals in NIST and NIOSH that they've allowed us to compile these photographs and this PowerPoint to be able to share with Portland. It was a tremendous amount of weight as this evidence started building to somehow have to wait until the final solution and the final evidence was all compiled before I was able to share any information with our department and the fire service. And so I just feel thankful that they freed up these photographs and allowed us to be able to share them so that we can hopefully learn from them. This disclaimer that the chief talked about, I would just again like to emphasize, these are NIOSH and NIST photographs, and they're part of an ongoing fire fatality investigation. And we just simply cannot get these photographs and copy them or transmit them in any form. And obviously, as the chief indicated, the sensitivity and the nature of that, I think, is pretty self-evident. What I'd like to go to now, Chief, if it's okay, is the first photo. As I said before, we really had not dealt with this in the past. We certainly had melted visors, and we'd had bubble helmets, and we'd had people with second-degree burns on parts of their body. But what became most unusual about these fatalities, quite honestly, was the degradation of the lens itself, but yet at the same time, and I'll try to see if I can get this mouse to work, but the pristine quality of the rest of the mask. And in this case, you can see that we have the lens itself has been horribly impacted, and yet some of the rubber components, silicone components here, and the head net itself are basically unscathed. In this next photograph, we have a lens that, again, these are the masks that were taken off fallen firefighters. And there are a couple of things that I'd like you to notice here, because they will, I think, be telling as we go through this. One thing that I'd like you to take note of is the bottom part of the mask here itself. It is basically like it's out of the box. The numbers, the serial numbers, all the indicators here, the VIN numbers are in pristine condition. Yet you can see a clear line of impact just above the number 2. And as you progress further up the mask, you see more impact, and then obviously the lens is gone. In addition to the clear line, the marked line of impact, and I will tell you that that line is exactly where this individual's hood was. So we know that the hoods we have are doing a remarkable job, doing the job they're intended to do, and that's protecting us from thermal impact. In this case, you can see that it virtually did not touch this SCBA face piece here, but the exposed components of the SCBA mask were significantly impacted, and of course the lens is gone. Now, another part that became telling to us was the fact that this mask, as you see, kind of, if a number of you remember kind of some of our basic firefighting lessons we had going through training, like the light bulb in the ceiling telling us where the hot spot of the building is. This, in the same regard, is telling us a little bit of a story. And that, as you can see, this mask is ballooned out. And what that has come to show us, and we've been able to duplicate, is that at some point in time, exposed to certain heat, this lens started liquefying, and it was still intact, but it actually starts inhaling, it starts expanding and constricting based on inhalations and exhalations, and it appears that this is the case with this one. This next one is, again, another mask that was taken off a fallen firefighter. All this evidence at the top and around the edges, is not the rubber itself and the silicone component of the SCBA, but again is just the residue from the lens itself. But again, take note, the snaps, buckles, straps, the head net, all those components are just in perfect shape. This is another example of that, and again the head net just like it's brand new, and the lens is gone. This firefighter, as he was overcome, fell forward. There's a hole here in the mask that is kind of scrunched up now. You can't see it very well, but this mask obviously was in a pretty liquefied state, and that's why it collapsed the way it did when the individual fell forward. But again, all the other components, relatively good shape.
Dan, are we saying with this photo right here, are we saying that was the firefighter here still breathing?
Yes. In every one of these cases, Chief, that I've shown the photographs, every one of these cases, the autopsy results were that the firefighter was still breathing when their lens went away. They died with heat trauma to their airway. They were still breathing when their lens went away. The other part with this that is part of, I guess, where we're going to end up going, and some of the compelling evidence is that their turnouts were in relatively good shape. And so that's kind of the point of where this investigation went to. After these incidents occurred, rightfully so, with myself being the chair of that committee.
And just real quick, the chair of the committee you're on, I know you're on 3 committees, and you're on the respiratory, you're the chair of the respiratory committee, which oversees the SCBA.
I chair the respiratory protection committees.
Yeah, respiratory protection, 1981.
1981 is one of those, right.
And then you, what are the other 2 that you sit on?
I sit on the technical correlating committee, which is, there is a committee that is the, is like the overseeing committee for all PPE, helmets, gloves, boots, turnouts, respiratory protection, and there is a committee that is the technical correlating committee that oversees those committees. So I chair the respiratory protection committees, and I sit on the TCC, the technical correlating committee, and I also sit on the training committees. That would be like NFPA 1403, which is live fire training, and SCBA training, and so on.
Okay, super.
Okay. Anyway, as I was saying, because of that association with the NFPA, rightfully so, the first questions that were asked me by the fire fatality investigators, as well as some of the departments that lost firefighters, was, what have you done? And rightfully so, it's a good question. What have we done? Since I came in the fire department, I know since the chief came in the fire department, nationwide, we have had very little evidence of this kind of impact, thermal impact to the SCBA lens. It's been relatively new. So I think it's a logical question to say that if we're designing SCBAs, what have we done that now would allow that? The unfortunate answer to that question is we haven't done anything. We really have not done anything. There have been no changes, no significant changes to SCBA lenses in the last 15 to 20 years. There really has been nothing that we have done that we can look at and say, we see what happened here, and because of this change, we're seeing it manifested itself in the field the way it is. It's just not been the case. So when we knew that we hadn't changed anything, we hadn't lowered the standard, we hadn't required some new type of a polymer or lens that we could point to, we had to start looking somewhere else, at least at what things in the fire world had changed. And the second question was simply that. What else has changed in the fire world that could possibly have had an impact in this area? And that was the question that was posed to us, and that was the question that we gave to the task group to deal with. If we know it's not SCBAs, if we know it's not what we've changed, then what has changed in the fire world that could potentially have an impact? Is that clear so far where we're going?
Very clear. Very
okay.
Clear. Hopefully that's clear. I mean, to the members as well.
Well, here's something that has changed, and this was somewhat compelling. Now, and I'm not pointing to this at this point as good or bad or indifferent. We're just identifying at this point changes. What has changed? One thing that has changed is turnouts. When I came in the fire service, and Chief, when you came in the fire service, in fact, we were bunkies there for a short period of time. So that was relatively the same time. We had turnouts that were basically cotton duck, cotton liners. We wore hip boots, no hoods, relatively cheap gloves, and whether that was good or whether that was bad, we just simply know that that has changed. It hasn't changed because we're just buying different turnouts now. We know it has changed because the NFPA standard requires them to be different and perform different than those turnouts we used to have. We reflect that change in what's called TPP, and this is thermal protection performance. When we came in, we had a TPP level of our turnouts that was very, very low. And you know, they worked. I mean, we went into fires and they worked. We had to do our job a different way than we have to do our job now. Right now, Portland is probably average for the nation. We have a TPP level of somewhere in the neighborhood of 42, 43, 44, somewhere in that range. And that's pretty much the case with the nation. So one thing we know is that turnouts have changed. The standard has changed, and we physically know they are different than they used to be. The next thing that we know has changed, and we know this by virtue of what our investigation has shown and fire departments based on near misses and just the way we do our job. Primarily because of the fact that the turnouts have changed, the way we do our job has changed. We might not get to maybe pat ourselves in the back and say that 30 years ago we were very, very disciplined in how we did our job. But because of the physical characteristics of our turnouts, when we went into a fire, we had to stay low, and we had to ventilate before we got in, and we had to have a charged hose line. A bunch of those elements of the fire ground had to be into place because what was exposed was our skin, and we just certainly couldn't endure that or absorb it. We were also primarily dealing with convected heat currents and not radiant heat currents. That's changed. Mm-hmm. Right now, I say that turnouts have changed our discipline because, quite frankly, we don't have to go in low. We don't have to. They protect us well enough that we don't have to. We don't have to ventilate before we go in, and we see that as a common occurrence. And we don't have to have charged hose lines, and we can go into fire standing up and be relatively comfortable. The other thing that's changed is fuel. I have a UL tape here that was just released this August, and I know some of you chiefs have already seen it. But it's quite compelling. It's what we call the legacy room. These rooms are identical in size and shape and preconditioning. They have different furnishings, and one is a legacy from 25 to 30 years ago, and one is from modern furnishings and draperies and that type of thing. The difference between those fuels and the old fuels is unbelievable, and you'll see that. I think it's quite compelling. With the fuel, what's changed in addition to that is the heat. This fuel produces more heat. We know it does. And because it produces more heat and a higher heat and a quicker heat, the time element has been significantly reduced. So we aren't necessarily looking at these bullet points that I brought up, turnouts, discipline, fuel, heat, and time, as the answer to our investigation. We just are simply saying that these things we knew had changed where we knew the SCBAs hadn't. So it compelled us to have to look at them. Were these potentially, one or all, potentially part of what we're seeing now as this problem? This video here is supplied to us by NIST, National Institute for Standards and Technology. It is a mannequin with a camera inside the eye, And this is a radiant heat fire producing about 8 to 9, 10 kilowatts per meter squared of heat. And I want you to pay particular attention when the lens start crazing. You will see, this is fast forwarding, that the lens is starting to move in and out with inhalation and exhalation. And you can see that now in real time, that this lens is moving in and out with inhalation and exhalation. At this point in time, you might not have anything other than a crazed lens when you exit the fire. Now, we're going to run this all the way through, and eventually we will create a hole in the lens. Obviously, at this point, our air is compromised, our airway is compromised, and we're in the same boat that some of these fatalities were in, unfortunately, before they died.
Superheated gas.
But here I guess is the point, and I'd like to make this a little clearer so that you might understand this a little bit better. Not speaking down to you, Chief, or anybody else.
I don't mind. Everybody does.
But just to make it clear, because when you start talking about kilowatts per meter squared, you know, we're fire guys.
Sure.
And you know, that starts drawing your knees up to your chest. A comparison to kilowatts per meter squared is that 1 kilowatt per meter squared is about what we get when we are sitting on the beach in the sun for about 20 minutes. That's about 1 kilowatt per meter squared. At 16 kilowatts per meter squared, in about 5 seconds of that impact on our skin, we will have second-degree burns. So now we got what we can understand with 1 kilowatt. Now we can understand with 16 kilowatt. This particular test was done at what we were determining is more representative of the fire ground that we're encountering on a regular basis, and that was 8 to 9, 10 kilowatts per meter squared. So this was not some unusual situation that we put this mass through. This was normal stuff. This is stuff we encounter on a regular basis. Now, one thing that was different here, and I would contend is different now with the fires that we're in, is this was not convected heat. When we started doing these tests originally with NIST, we were using convected heat, same temperature with convection as radiant heat. What we were amazed at is the damage that was caused by radiant heat as opposed to convected heat they were incomparable. They were incomparable. And so this test we did here was with 8, 9, 10 kilowatts per meter squared in the time frame that you saw, and it was breathing at 40 liters of air per minute. So it was on the low end of the demand that we would put on this mask. Typically, we're breathing 60, 70, 80 liters per meter squared. So theoretically, we could have a greater impact on that expansion and contraction of the lens than what actually was demonstrated in this mask. So, point being is that when we're going into fires that we are going into with the equipment we have now, and this dummy was wrapped up, or this mannequin was wrapped up in normal turnouts in the 40 range of TPP. The primarily exposed component of the PPE was the lens, and we saw what happened to it. Now, one part of it, when we started seeing this move, and this did this work for us, we slowed it down and said, I want to see that again, because we started seeing that mask move in and out. We started seeing the mask move in and out on inhalation and exhalation when the physical evidence, if we would have stopped right then, would probably have just been crazing. So what made us very, very concerned was that we potentially, when we are in a fire and we would come out with crazed damage to the lens, we could have had the lens in a softened state to the point that I think it would not be a long, hard push to think that if your mask became crazed or discolored and it was hard to see, we would typically wipe our mask with our gloved hand. If it were in that softened state where it could move in and out, we could potentially pull the lens right out of our mask. Anyway, this was released by NIST, and I think it was a pretty interesting. Had a lot of information with this test they did for us.
I have a quick question.
Yeah.
So we're going over this mask. Say the masks from the different manufacturers.
Mm-hmm.
Is there a difference from one manufacturer, or are they basically the same?
You know, basically
For the
the
lens.
same.
Basically the same.
Lenses are made primarily the same, with the same plastics, the same molding process. Some of the lenses are different shapes. So theoretically, they could have a flatter surface, maybe exposed to radiant heat more than a rounded surface. That could make a difference. But every test we did, they performed almost identical.
And what I noticed earlier with the different masks from the fallen firefighters, they look like different types of masks. So it wasn't like one type of mask.
Yep.
It was,
You're
so whether
correct.
it was manufacturers or different.
That's right. It's a good
styles.
observation, and because that's a fact. This would be a pretty easy hit if we found one manufacturer. We could say, you know, you're doing something. Something's not right, and we'd go that direction. It was across the board. It was across the board. And so because it's across the board, that's what makes it information we need to have in Portland. Because
Sure.
because I think we're clearly not identifying any one manufacturer, but we're certainly not excluding any one manufacturer. Okay.
All right.
This next video was released by UL. Some of the members of the department have already seen it. What it is here are two rooms, and I explained it briefly earlier. And it's two rooms. The one on the left is the legacy room that housed furnishings and drapery and those types of components from 25 to 30 years ago. And the one on the right is a modern room, same exact room, same dimensions, same heat, same ignition source, but just the different fuels. Now granted, we don't have rooms now that perhaps have the full room full of legacy or the full room full of the new modern. But we have, where before the legacy, we primarily had almost all of it was the legacy because that was the only materials available. Now we have a mixture, perhaps of old and new, and maybe not completely the new modern. In the beginning, you can look over here where my mouse is, and you can see that in the legacy room, it appears that it's actually not doing quite as well as the modern room, because the modern room ignition point is exactly the same place. And this one you have a visible flame, and over here you don't even have a flame yet. What is amazing about this is we're realizing that the modern man-made materials end up actually producing more fuel. And so the one on the left tends to be burning cleaner. This is actually not burning as well and producing more fuel and becoming more volatile. In a relatively short period of time, now 1 minute and 24 seconds, you see a significant difference between the legacy fuel on the left and the modern fuel on the right.
Well, it's got a trend starting already.
That's right.
Yeah.
Now, typically, this is when somebody's running to the phone and calling the fire department and saying, I got a problem here in my house. And so we get the tap out, and we're starting to move at this point in time. Now, over here on the left, legacy, we still go in with a pump can. We don't have much of an issue. Very, very quickly, we're realizing we got a little bit of a fire starting here with 2 minutes and 1 second. Now, perhaps we're on the road now. We're jumped on the rig and we're going down the road, and maybe we're within that, hopefully that 4 minute response time. We're just down around the corner. And as we said before, we would hope that perhaps with this new fuel that it would get to this volatile and flash over temperature earlier or later. Unfortunately, when it hits its maximum is at about that 4 minute mark. And so that's just about the time we're getting there. So now all of a sudden we're talking about, to validate what I brought up earlier regarding some of our bullet points, the fuel has changed, and the new fuel makes it hotter, and because of that heat it actually uses up our time, and so we've lost some time. This is amazing. At 2 minutes and 54 seconds, not quite 3 minutes, the legacy room on the right, it's still a pump can fire. The one on the right, we got a fire.
You got a fire. It's amazing. Stuff's already falling off the ceilings.
That's right. We're at 3 minutes now. And every other component in these rooms are identical, short of just the simple furnishings.
You got flashover. Wow.
And so what we came to here after repeated tests with this exact same situation, with the exact same components, is we were hitting this kind of flashover in 3 minutes and 40 seconds with the room on the right. And you can see now we still have we have an inch and a half. We have an 1 3/4 inch fire here on the left. I mean, we have a very manageable fire on the Legacy, and we have a significant fire on the right. So I think we can safely say, again, to reiterate, we know that turnouts have changed. We know because the standards changed and the requirements have changed. We know that the fuel has changed, and we know that heat has changed, and we know the time has changed. Those are significant issues. Any questions on that, Chief?
At what time? Yeah, I'd love to hear. What time do we hit?
We hit the same flash on the Legacy room in about 30 minutes.
So I got to look at my ego a little bit here.
Yeah.
Does that make us back in the day? Better or worse?
Well, we've got a comparison here at 25 minutes and 6 seconds, and I think it actually says something. I think UL put that in for us. I don't think that was just my my smarts that came up with that number. I think I actually saw that, but I believe flashover occurred with Legacy right at about 30, 29 something. To come to the same point that we came to in 3 minutes and 40 seconds.
Wow.
What a significant impact that has made on the fire service and how we do our job and the time we have to do it.
Well, this would take us back to where you talked about convection heat versus radiant heat.
That's right. Because when we first would have come into that room on the left, that heat would have gone to the ceiling, started banking its way down, and we'd have been dealing with convected heat.
Yeah.
That's what we dealt with primarily. When we came into the fire on the right, we were almost immediately dealing with not only convected heat, but dealing with radiant heat because of just the size of it.
This would make sense for, I know we're going to a new slide here,
Yeah.
but we just had a close call, near miss, with 2 of our firefighters that had a report of somebody trapped inside a structure, a little boy with his dog. And as they forced their way through the front door and were greeted by nothing but a wall of fire, they had an exposure of 3 to 5 seconds. Burnt turnout coats, the entire right side by their knee pads, their helmet, crazed, as you were talking about with the lens. And that was 3 to 5 seconds.
You know, and that time frame is not unusual. That's exactly what we're finding.
Yeah.
And again, we're talking about, for the most part, this significant difference that we never would have guessed between convected and radiant heat. We used to experience it, and perhaps a number of firefighters out there have experienced it, when you got into a fire and it's just hot. It just puts you to your knees because it's hot. And then all of a sudden you poke your head around the corner and you get blasted with something. That becomes really the difference between that radiant heat, or the convected heat we're dealing with, and the radiant heat. What has become part of the blessing, I guess, with the new TPP levels of turnouts, is that we have very well protected our skin from those kinds of impacts and assaults. But at the same time, we find firefighters that are into these situations and perhaps are not dealing with the radiant or the convected heat as much as we're dealing with the radiant heat, which tends to be the most destructive, and are relatively comfortable. I know that even in the situation here in Portland, the difference between one firefighter indicating the thermal assault that he took versus the other, and the real difference was one had ear flaps down and one didn't have ear flaps down. That's not a big deal. I mean, that's a thin layer of thermal protection, but that thin layer of thermal protection can make that kind of difference in your comfort level. And so we found that to be tremendous. And so what becomes a blessing on one hand with the thermal protection we have with the TPP levels have really made us have to come to a point of better understanding the atmospheres we're in, because we might not be able to determine that by what we feel on our bodies. You just simply won't.
Situational awareness.
That's right. and understanding the dynamics of what we're in, and adhering to those disciplines. I was asked to present our initial findings from this investigation and make recommendations at the Emergency First Responders Respiratory Thermal Characteristics workshop. That was in Pittsburgh, Pennsylvania. It was hosted by NIOSH and the NFPA Research Foundation. NIST was there as well. And I went there to speak to our investigation jointly with the fire fatality investigators about what our initial findings were. And I'm going to read this. We don't have to go to this slide, but I just wrote it because it was exactly what I told them. The research into these areas was very complicated and very often revealed unanticipated issues. As I said, we went into this to find what the problem was with the lens. As we started doing our research, we started dealing with things like turnouts and fuel and heat and so on and so forth. I believe the research and investigation at this point, and this was just a few months ago, speaks very clearly to one primary area of concern. My presentation at the workshop and my personal belief is that the improved thermal protection of the firefighter's outer garment, turnouts, has reduced the firefighter's sensory ability to recognize catastrophic thermal environments. Not only is that my conclusion, but that's the NIOSH fire fatality investigators' conclusion. And just to give you an insight into that individual, those individuals, they're career firefighters. One of the investigators was a safety chief with Virginia Beach Fire, retired and went to work for NIOSH. And so these are firefighters that clearly haven't, these investigators rather, are firefighters that really have an understanding of what we used to go through, what we go through now, and have been not just a part of sitting in an office or in one side of the apparatus, but been inside. And so this is their conclusion, and this is exactly what the task group's conclusion was as well. We are presently working now with NIST and the University of Texas, where they're doing some work for us that is involved in repeated exposure. See, we're talking about here with our initial tests that were a one-time assault on the thermal impact. We're now working in the area of repeated impacts. One of the examples that we had that we're looking at, and we have been looking at, is a fire instructor in Pittsburgh, or in Pennsylvania. And he ended up dying with his lens degrading, melting away, and died from thermal impacts to his airway. But prior to him going in, and the time that he actually went down, his mass was observed to have had crazing. And they had been into multiple fires that day and previously. And so what we're working on now with NIST's help and the University of Texas help is to see if, in fact, there is even a greater possibility of this kind of reduced stability in the lens if we've had thermal impacts over a period of time. So that's still in the ongoing process.
What do you think is going to happen there? I think immediately to Station 2, our training center, the West Wing, where they're doing the house burns.
Well, I think what we've already seen so far is that I believe we're going to end up with evidence that shows us, in fact, there is. Because I think what ends up happening is that we have these lenses that become thermally impacted, and they become semi-soft, and they start losing their integrity because they start becoming, flowing plastic again. And then they cool off and they snap back and they become rigid again. And then we do that same thing again to them, and we repeat that. And I think clearly we're seeing that there is some evidence that they just, with those kind of thermal impacts over a period of time, don't hold up as well as a brand new SCBA out of a box.
Sure.
So the question is, and this is this next slide, and it really, I think, becomes the compelling question and why we're here and why we need to analyze this and ask the question, is better really better? This becomes somewhat of an arms race. We try to make it better. But at some point in time, are we encapsulating ourselves with protection that puts us in an environment that reduces that line so small between life and death that now when things go to garbage on us, they're just done. And as you said, Chief, the situations we're talking about, we know by the transcripts and we know by radio communication, these were not 5-minute, 10-minute, 15-minute situations. They were second situations. They were situations that had them in environments that were so hot and in radiant situations, radiant heat situations with exposures of seconds and not minutes. And we had that kind of degradation. In some cases, we had no communication at all, at least any evidence that they were feeling any discomfort until their lenses went away. So the question becomes, is better really better? And at some point, do we need to analyze how well we thermally protect ourselves, and is it potentially hampering how well we do our job? The question now is, are we making changes to NFP in 1981? That's the SCBA committee. That's the one where we design SCBAs, and the answer is yes. We are. And we have a standard right now that we're going to have as part of the 2013 standard, and that's 500 degrees F for 5 minutes. That's one standalone test that we're going to have. But probably the biggest one is this one. 15 kilowatts per meter squared is going to be the impact that we're going to have, and that's a 5-minute test, 15 kilowatt per meter squared. As I demonstrated or explained before, 1 kilowatt per meter squared is at the beach for 20 minutes. 16 kilowatts per meter squared is when you burn yourself, you burn your skin in about 5 seconds, second-degree burns. The test that I showed you from NIST was 8 to 10 kilowatts per meter squared, and you saw what kind of degradation there was to the lens at that point. This test is 15 kilowatts per meter squared, significantly higher. And this is the result. These lenses were exposed to 15 kilowatts per meter squared from 3 to 4 minutes. In reality, most of these received the damage they received in less than 3 minutes. But one of them ended up actually going to right at 4 minutes. And so that's why we put that 3 to 4 range in there. But most of them failed below 3 minutes. So that is going to be what the new standard is. And quite honestly, what that tells us is that the probability for an existing lens on the market today is not going to pass. Almost assuredly, every manufacturer is going to have to do something different. What that something different is, we don't dictate that. We dictate what the performance requirements are and what the testing criteria is, and then they have to figure out how to make it work. I was asked the question after we plugged in the 500 F for 5 and 15 kilowatts per meter squared, if this is going to solve the problem. In addition to the 15 kilowatt per meter squared, this is not convected heat. This is a radiant panel test. So we're doing 15 kilowatt, or we're doing 500 F for 5 minutes, and that's convected heat. We're doing 15 kilowatt per meter squared with a radiant panel test, so it's entirely different heat physiology, if you will, that's going to impact the lens. I was asked the question, though, is this going to solve the problem? And unfortunately, my answer was, and still is, no. It's not going to. It's not going to solve the problem. And there's a number of reasons. This is the biggest reason. Everything we design has some limitation. We will never be able to make equipment that will take the place of the fire service knowing what they can and can't do and requiring the discipline to stay within those limits. We're never going to make something that you can walk on the sun. And so there's always going to be a weak link or something that's going to fail. And we just need to realize that. We're never going to solve this problem entirely. But what we're hoping to do, and becomes the point of my next slide, what we're hoping to do, and I'll encapsulate it in a nutshell, and I actually have it written down here, is that we are trying to propose to the Technical Correlating Committee that we have an overriding standard that affects all PPE ensemble, and that the PPE ensemble identifies basically, of all these components of the PPE, which one needs to be the last soldier standing. if everything's going to fail, which one do you want to still be working? And that's what we're hoping to do.
I know what I want.
Well, I know what one I want as well.
Yeah.
Here's the question: is there anything we can do now? And the answer really is yes. And this first bullet point, and I want to take a little time to explain this one, because you out there in the station house might have already heard about this one. It certainly has been recognized nationally. But we had 2 firefighters in the city of Houston that died. They died because of this. Their lenses went away, and both of them died as a result of that type of thermal trauma to their airway. This chief called me personally. What have you done? Why are my guys in the situation they're in? What have you done to the SCBAs to make this happen? And I've already told you what my answer was, and still is. When we went to the workshop, we had Houston, and I'm not speaking out of turn here. I've already told them I'm going to share this with Portland. We had Houston show up at that symposium, that workshop, and they brought not only their turnouts, but they brought up some of their masks. And as I said before, we have a TPP level of probably around the 42, 43 range in the city of Portland. I had never seen turnouts before like Houston had. They had layers that I'd never seen before. And the hoods that they had, where we have the Nomex hoods, they had hoods that were made of the same material as their turnouts. And their TPP levels were probably in the neighborhood of 100. And the only exposed component of their ensemble, of their SCBA, was primarily the lens. We can certainly point the finger and say this or say that. Obviously, Houston's intent was to protect their firefighters and give them the best thermal protection they could possibly have in a fire to protect them. The question has to be asked, did you overprotect them to the point that now we found a weak link? Without question, we found a weak link. With that kind of TPP, we found a weak link, and the weak link was the lens. So the first thing we need to know regarding anything we can do now, we need to know what our turnouts are capable of protecting us from. And probably more importantly, what are they capable of protecting us from not knowing or allowing us to get into? The next one we know for sure is we know our fuels. We know the fuels are more aggressive. We know they produce more heat. And we just need to know that. We need to plug that into our equation of why we do what we do and what we can do and what we can't do. As I showed you with the legacy 30-minute flashover and the 3-minute and 40-second modern flashover, the fuels are different, they react different, and it reduces our time. And we're dealing with radiant heat much more than we ever did before, where we used to deal with convected heat. And we know that radiant heat is what's causing most of our problems, not convected heat. So we know the fuel is more aggressive and it impacts us more profoundly. We know that we have less time to do what we do and to make the decisions to do what we do. And we know that there is a tremendous difference between convected heat and radiant heat. And we know because of what we're dealing with, we're starting to encounter radiant heat where we never did before. And quite honestly, we're starting to encounter it standing vertically instead of even being down. The other thing we can do is perhaps look at some of those old disciplines that you spoke to before. Some of those things that were required before are really still required now. We just have equipment that doesn't make it physically as requiring as it was before, but the reality is the environment, if anything, is worse than it was before, and probably needs to have those disciplines in place more than it even did 30 years ago.
There's an interesting, when I became BC, probably my number one thing that I started when you start sitting back and watching an emergency scene and directing and trying to get things going on is firefighters standing up, going into a well-involved structure, and then the heat drove them down. Yeah. And a lot of times it was just too late. It was a melted helmet or something else, versus getting down on the ground and not crawling, but being on your knees, getting through there. Mm-hmm. And there's a lot of those old disciplines that it's human behavior. You just kind of get a little lazy, and it's not just young guys.
That's
or
right.
Gals. It's old and young, was my experience, and that right there in itself. And I'd say the number one thing that I would take away from what I'm seeing here is if we've got one potential weak link, it becomes an education piece, and recognizing if we can educate our firefighters, and they want to see the situation they're about to go into where they take a step back, and instead of getting in that go mode of got to go get some, you take a step back and looking at the environment you're about to walk into. What kind of box is it? That's a big piece.
That's correct.
So,
unfortunately, since I gave this presentation to you gentlemen on, I think it was the 1st of March or somewhere around that time frame, we've had one more firefighter fatality that involved exactly this situation. And I can't speak in detail about it or even what the location was, but some of the evidence was that he was standing up, superheated fire, and went in standing up, and then was driven to the ground. But it appears that when that occurred, it was because his lens had already degraded at that point, and the individual was actually retrieved by his partners about 6 or 7 feet from the front door, but had already expired. And we didn't have to do, the reality is we don't have to go in and stay low because our turnouts allow us not have to. The reality is we need to, but the reality is because of the protection we have, it doesn't drive us down like it used to drive us down. And so we just need to be aware of that. That's just a real fact. That it's something we perhaps, as you said, need to be very much aware of, because perhaps our turnouts are not going to push us down where before they would have, the environment would have.
Or lack of protection.
That's right, for lack of protection.
Yeah.
And so we just need to be aware of that. So those are some of the things that we can do right now. Here is what I said my proposal was, and that I submitted to our chiefs at EOPS. I wanted to propose to the TCC that we identify a predetermined design strategy sequence for PPE failure. In essence, what I'm saying, and this sounds like you're committing heresy here by talking about PPE failure, but in reality what I'm talking about is identifying not necessarily the failure of the PPE, but to identify which part of the PPE you want to be the last one standing. By virtue of identifying which one you want to be the last one standing, you're identifying a failure relative rate to the other parts of the PPE ensemble. I took a number of your suggestions and encouragements and went that next day to the TCC meeting in Orlando, Florida, in which case they gave me an opportunity to speak to this exact issue. Afterwards, the chair of the TCC, Les Board, who is the director of NIOSH MPPTL, said, you know what, we can't wait to move on this. We got to do something now. And he developed a TCC task group. That task group has members from the fire service, has members from NIST, has members from NIOSH, and from the fire fatality investigative team, all SCBA manufacturers and all turnout manufacturers. And unlike typical government types of task groups and committee work, he wants language by May 23rd of this year. So basically in 2 months, he wants to have language back about this aspect of identifying the priority in PPE and what that relationship should be between one component and the other. This is the question that the task group has. We must decide if there is any one component of the PPE ensemble that has a greater impact on firefighter survivability. This is what the chair of the TCC said to the TG. You guys come up with it. This is the answer I want you to add. This is the question I want you to answer. We must decide. If there is, and if there is, what is it? I personally believe it's the SCBA. Now, fortunately, I guess, for my opinion, is I was appointed chair of that task group. So the fact that I think it's the SCBA makes me able to push that a little bit more than somebody who might not agree with that. Now, they might get rid of me someday as the task group chair, but as of right now, this is what I believe it is. And I think, quite honestly, it seems like a no-brainer. And most of the fire service people involved in the task group and on the committee believe that it's the SCBA. That's the one we want to have standing when nothing else stands. But we're dealing with a lot of different agencies, a lot of different people who have different opinions, perhaps. So that's where we're going. At this point, May 23rd is my deadline. That's when we have to have language. And I would really like to, as this is aired, be able to give my information, if I can, my contact information, for any of the firefighters out there, any of the officers, any other chiefs that could have some thoughts on the issues that I've brought forward that I can bring to the task group, and criticisms and any other questions they might have. And so the last slide here is basically me. It's Dan Ross's. This is my cell phone, so I have it with me all the time. And I have a bureau email address, dan.rosses@portlandoregon.gov. And please, I would really encourage you. I anxiously wait for new information, for some insights that I don't have, which is a lot, and some directions that we just haven't thought about. And we need to be able to pipeline that right into the TG. So basically, Chief, that's the presentation that I brought before you before. That's the one I gave to the TCC, and I guess just personally, I feel thankful for NIOSH and NIST that they allowed me to have their photos, allowed me to use some of the product of their investigations that are ongoing, and I thank you for giving me an opportunity to come and speak today on this.
I think thank you, Dan. I think it's a testament to where Portland's trying to stay, current, and I think that our firefighters, they want this. And they want to be part of the solution, not part of the problem. And I'd also like to say, if anybody doesn't get a hold of Dan, you can also forward emails through me or call my line, and I'll make sure Dan gets it. But I thank you very much for your time and effort.
You're very welcome. And, it's an honor.
I know the one thing that I've always known about you is how much you love airports and how much you love to travel.
Yeah, I'm built to sit in those coach seats.
Yeah, that's so I think that's all.
It is not my love, but you know what? I feel honored, and I feel blessed to be able to be involved in the things I'm involved in, and that's just a small price to sit on a plane. However often I sit on them.
You know what I think, Dan, is awesome is that we could go from when we were in training, or when we go back to PCC when you and I were there, and you were going to do fire service and go into that, or you're going to do the swimsuit model thing. and for you to go into the swimsuit...
I still might do the swimsuit thing.
Well, yeah. You can do that later. But for you to get into this and, so to speak, dive right into it, I think that's great.
Yeah, thanks for reminding me.
Okay. Well, thank you very much, and let's be safe out there.